Okay, in this lab session we will look at the binomial and the Poisson distribution. For the first exercise, soft drink containers are filled automatically and it's acceptable if 5% of the containers contain less than the quantity printed on the label. A random sample of 20 containers are selected and the quantities measured. We define a random variable x as the number of containers out of 20 that contain less than the quantity printed on the label. So first of all, we have to give the distribution of x as well as the mean and the variance of x. So we can recognize this as a binomial experiment because we have 20 independent trials. Those are the 20 containers selected at random. And the probability of a success, which will be that a container contains less than the quantity printed on the label, the probability of success will be 5% for each of the selected 20 containers. So we can say that x, follow the binomial distribution. My first parameter n, the number of trials, is 20, and my success probability is 5%. So to get the mean and the variance, the expected value of x is n times p, and that is 1. So the variance of x is 0.95. The next part, from the 20 containers, 3 are found to contain less than the required quantity. The supervisor maintains that this is normal for a process of this nature. Would you agree with that? Okay, so if indeed only 5% of the containers contain less than the quantity printed on the label, is it normal that as many as 3 or more containers will contain less than the quantity printed on the label? So we want to calculate the probability that x is greater than or equal to 3. So that is the probability that x is 3 plus the probability that x is 4. We add them all together up until the probability that x is 20. So this is a lot of calculations, and we can also write it as 1 minus the probability that x is less than or equal to 2. Okay, now we substitute this into the formula for the binomial distribution. So for x equal to 0, it will be 20 combination 0, 0.05, the success probability to the 0, times 0.95 to the power of 20. And in the same way, to find the probability that x is 1 and the probability that x is 2. And if you do these calculations, you should get the following. Okay, we can also easily do this in Excel. So if you go to the insert function and you select the category statistical, then you can go down to the binomial distribution. First of all, to find the number of successes, we want to find the probability that x is less than or equal to 2. So The number of successes that we are interested in is 2. The number of trials is 20. The probability of success is 0.05. And then, because we want to find the probability that x is less than or equal to 2, we put in, for cumulative, we put in true. If we wanted to find the probability that x is equal to 2, then we would type in false. Okay, so we find the probability of 0.9245, the same as what we got by calculations by hand. So we still need to subtract this from 1 to find the probability that x is greater than or equal to 3. So I subtract that from 1 and we get the same answer that we did by hand. Okay, let's have a look at exercise 2. Patients arrive randomly at the rate of 1,8 per hour at the emergency services of a small hospital. So we define our random variable y as the number of patients per hour that arrive at the emergency services of the hospital. And first of all, we want to give the distribution of y. So y will follow the Poisson distribution because we are counting the number of scarce events in a certain time interval. So the arrival of patients at the emergency service is a scarce event, and the time interval that we are interested in here is an hour. So we can say that y follows the Poisson distribution and the parameter is 1.8. Now suppose the doctor on service would like to take a 30-minute nap. What is the probability that no patients will arrive during a 30-minute period? So now we can define another random variable. Let's just call it w. So w is the number of patients that will arrive in a 30-minute time period. So w will also follow the Poisson distribution, but the parameter will now be 1.8 divided by 2 because we are now looking at a 30-minute time period and not an hour time period. So it will follow a Poisson distribution with parameter 0.9. And we want to find the probability that w is equal to 0. So we substitute it into the formula for the Poisson distribution. So it's e to the minus mu, so 0.9. And then 0.9 to the power 0 divided by 0 factorial. That is then equal to 0.41. Suppose the doctor works a 12-hour shift. What is the probability that more than 10 patients will arrive at the emergency room? So let's define the random variable v as the number of patients arriving in a 12-hour time period. Then v will follow a Poisson distribution, and my parameter will now be 1.8, and now I multiply by 12 for the 12 hours. So that's a Poisson distribution with parameter 21.6. And we want to know what's the probability that more than 10 patients arrive. So that's the probability that v is greater than 10. So again, we can write it as 1 minus the probability that v is less than or equal to 10. Now this is a lot of calculations that we need to do to find this probability, and we would rather make use of Excel. So we are going to first of all recalculate this probability of 0.41, and then we will also find the answer to this question in Excel. Okay, so for my insert function, I go down to the Poisson distribution. My x for the first example, my x is equal to 0. I want to find the probability that no patients will arrive. My parameter was 0,9. And in this case, cumulative will be false because I want to find the probability that my variable is exactly equal to 0. So that probability is 0.406, the same as what we had when we did the calculation by hand. Then for the second question, again we go to our Poisson distribution. We want to find the probability that V is less than or equal to 10. So I type in a 10. My parameter is 21,6, and in this case, because we want to find less than or equal to 10, my cumulative is true, and that probability is then quite a small probability, and we want to find 1 minus this probability. So a very high probability that more than 10 patients will arrive within a 12-hour shift.